Resistors in series. The aim of this experiment is to determine the effect that resistors connected in series have on the total resistance, current and voltage in a circuit. We expect that resistors in series are voltage dividers. The total resistance will increase when resistors are connected in series, and the current in the circuit will decrease.
In this experiment, we are going to look at a series circuit. What happened to the potential difference when you increase the resistance in series, and what happens to the current when you increase the resistance in series. To start off with, we only have one resistor, and we've got a power supply. From the positive terminal, we come to the resistor, and then to the ammeter in series in this circuit, back to the power supply. And then across the resistor, we've got our voltage probe, which acts as the voltmeter. Now, what we are going to do is we're going to take a reading of the voltage and the reading of the current with just one resistor in this circuit. Now, take note that the power supplied by the voltage source is about 3 volts, or the voltage coming from the voltage source is about 3 volts. So let's see what the current and the voltage in this circuit is. We only have one resistor. Right, we're going to switch on the voltage and have a look there. Your potential is about 3 volts and your current is 0.21 amps. What we are going to do now, so that's only with one resistor. What we are going to do now is we're going to increase the number of resistors in series. What we have here is a 15 ohm resistor. We're going to add another 15 ohm resistor in series to this one. And then we must have a look at what happens to the current and what happens to the voltage. First of all, we look at the current. I have not even connected the voltage source yet. Have a look at the current. I have now 2 resistors in series in a circuit. The total current has gone down to 0.11 amps. So when I increase the resistors, the current goes down. Let's have a look now at the potential difference. We're still getting about 3 volts from the power supply. If I connect the voltmeter across both resistors, let's have a look at the voltage now. Voltmeter across both resistors, the voltage is about 3.07. If I take the voltmeter, connect it across one, let's call this one R1, the first resistor. Have a look at the voltage now. 1.53. If I move the voltmeter and connect it across the other one, and the voltage also about 1.54. We now need to go and discuss these results.
We can make a few conclusions from these results. The resistors are voltage dividers when they are connected in series. This is because we saw that the voltage over the resistor 1 added to the voltage over the resistor 2 gives us the total voltage. It is important to notice that the 2 voltage readings over resistor 1 and resistor 2 were only approximately equal because the 2 resistances were equal. If, however, resistance 1 was not equal to resistance 2, the smaller resistance would correspond to the smaller voltage reading. The total resistance increased from 15 ohms to 30 ohms when 2 were connected in series. We can then say that because the total current in the circuit was almost halved, it is not that effective to have resistors connected in series.